Okay, so this is for problem set 2, number 11. And we have to divide these two rational expressions. So the one thing to keep in mind is that when you're dividing fractions, that's the same as multiplying by the reciprocal of the second one, the one that you're dividing by. Okay, so I'm going to take first step and just rewrite this. P squared plus 3p plus 1 times, and then we'll have p squared plus 9p minus 10. So we flip that second one over. Now I need to factor these, and I need to see which factors are in common in the numerator and the denominator. Okay. So when I factor the first one, that's going to be, let's see, p minus 2 times p plus 1. Okay. And the denominator, let's see, we're going to have 2p and p and 1. P minus 2. So those are all the factors, and let me just real quickly work through one of those just as a quick review for factoring. So let's look at 2p squared plus 3p plus 1. I'm going to multiply the first and the last together, so 2 times 1 is equal to 2. I want two things that when I add them together, when I multiply them, didn't say order, that it equals that same thing, but when I add them, it turns out to be that middle coefficient. So when I add them, it needs to be 3. So that would be 2 and 1. 2 times 1 is 2, 2 plus 1 is 3. And we're going to take that middle term, and we are going to take that and split it into two pieces, a 2p plus a 1p. And then I'm going to factor by grouping, and I'm going to look at these first two, and what is the greatest common factor for that. So the greatest common factor would be 2p, and if I factor that out, I get p plus 1. And then when I look at the second two terms, okay, well, the biggest thing that divides into those is a 1. So I'm still left with p plus 1, and then p plus 1 is in common, right? So if you look at this, there's a common factor right here, a p plus 1 that I can factor out. And then it leaves me the 2p and the plus 1. Now remember, it doesn't matter what order you write the factors in. Okay. Now I just want to compare, back to the problem at hand, what do we have in common in the top and the bottom? And I see a p minus 1 and a p minus 1 there. That will divide out. And then a p minus 2 and a p minus 2 there. And a 1 plus p and p plus 1, those are actually the same thing, right? I even said that backwards. I don't know what I'm doing. So we got our p plus 1s, and that just leaves me then the p plus 10 over 2p plus 1 as my answer. Okay. Now we had one more, which was number 17 that I got asked. So this is number 17. Solve the quadratic. Use the quadratic formula. Since that's the instructions, I'm going to go ahead and do it. You could do this by other means, completing the squares or something, but remember the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And the number in front of x is squared is your a. The number in front of x, that's your b. The number that's a constant is your c. So in this case, the a equals 2, the b equals a negative 7, and the c equals 1. It might be a very good idea for you to write these down, okay? Most in particular because it helps with sign errors. It's a 2-second thing to write it down, but it does often help people with sign errors. And now we just need to make our substitutions. So negative b b is -7, so then we got b squared minus 4 times a times c all over 2a at, so that's 2 times 2. So negative, negative give me positive, and my minus didn't show up there. Square root of 49 minus 8 over 4. And it's a good idea to worry about the discriminant, or the part that's under the square root, first. And then we do need to check to see whether that square root will simplify. 41's prime number, so it's not like we can factor anything out, so it is simplified, and that is our solution. People make, the biggest mistakes that people make with the quadratic formula are signs, okay? Pluses and minuses, things like that. So you've got to be real careful with all your positives and negatives. Hope this helps.